Okay, let's take a look at the warm-ups here. These are going to be from the warm-ups that we started here a little bit ago. So we're trying to write this in quadratic form, and we want to state the vertex. So on a problem like this, we want to get this completing of the square done. So I'm going to just move this 11 over a little bit. And when I do that, then I'm going to take half of this and square it. So I'm going to add 9 here. But what do I have to put here? Minus 9, because I have to keep it equivalent to what I started with, and this would. So now I'm going to have y equals, I look at this, that's going to be x minus 3 quantity squared plus 2. So this is the vertex form of that equation we were given. So what is the vertex? 3, 2. We have a shift to the right, 3 up 2, and that's going to be the vertex. Okay, number 2. On number 2, we're trying to find x-intercepts. If I want to see if this function even has x-intercepts, I could graph it. I could do 5x squared minus 9 and graph. And I can see, yes, it does have x-intercepts. So now I need to be able to find those. So to find x-intercepts, I'm going to plug in 0 for x. And so I'm going to add 9 over here. I'm going to divide by 5. And I get x squared equals 9/5. I'm going to take the square root. And I wanted to show you this part right here. I have to put plus or minus. What's the square root of 9? Can we take the square root of 5? No, so we're just going to leave it radical 5. But we don't want to have irrational numbers in the denominator, so I have to do what's called rationalizing it. To rationalize, I'm just going to multiply by radical 5 on top and bottom. So on the top, I'm going to have plus or minus 3 radical 5. On the bottom, what's radical 5 times radical 5? Radical 25, right? So what is the square root of 25? 5. And so this would be the correct answer for the x-intercepts. And really, it's better to write these as points. So it would be better to put 3 radical 5 over 5, 0, and negative 3 radical 5 over 5, 0. We typically want to write those x-intercepts as points. There is a way you could check this too. It doesn't feel like there should be a way, but you can, because you can go to y equals 0 and you can put this in here. I'm just going to find this one here. I'm going to do second trace calculate, intersect. I'm going to get over there close to it, and I'm going to enter, enter, enter. And it tells me that it should be 1.34. Well, I'm going to see, is 1.34 the same thing as 3 radical 5 divided by 5? And it is. See how it's 1.3416, and that's the same thing I got? So that tells me that we're correct. Okay, x-intercepts of this. What'd you guys say on this? Okay, those are not x-intercepts, because when we're talking about x-intercepts, it has to cross the x-axis. If I were to put in x squared plus 4 and graph it, that is a parabola that's been shifted up 4 units. Is that crossing the x-axis? No. So the way we know this doesn't have any x-intercepts is when I plug in 0 here and I start solving it. Some of you said it's plus or minus 2i, but when this happens, when I get imaginary solutions, that means there's no x-intercepts. Now, it's true there are no x-intercepts, but there still would be zeros. A 0 is simply what makes the function equal 0. Okay? So when we were solving this just a minute ago, we got negative 4 equals x squared. And what does x equal? What's this simplify to, you guys? Plus or minus 2i. So we do still have zeros, but we do not have x-intercepts. So which is true? We always have x-intercepts, or we always have zeros? We always have zeros, but we do not always have an x-intercept on a problem, okay? There will always be some value, and that's really why imaginary numbers were created, was because we want to have solutions to any problem, and now we can once we introduce those imaginary numbers, okay, to any quadratic equation. All right, this last one, this was tough. Said one leg of a right triangle is 2 units longer than the shortest leg. The hypotenuse is 3 units longer than the shortest leg. Find the perimeter. All right, so we're going to have to draw a picture of a right triangle. I'm going to call this the shortest leg, it's x. What was the other one? X plus 2. And what's the hypotenuse? X plus 3. So now if I want to find out what x is, I have to use a squared plus b squared equals c squared. I have to use the Pythagorean theorem. Well, I'll just call this a. So I'm going to do x squared plus x plus 2 squared equals c is x plus 3. C has to be the hypotenuse. So now we have x squared plus, well, x plus 2 squared. What is that quantity squared turn out to be? X squared plus, not just plus 4, but plus what? 4x, and then what? Plus 4. That's what that turns into. If you're not sure what x plus 3 squared is, write it out twice. What's the first times the first? X squared. The outers is 3x and the inners is 3x. So what's that give us? 6x. And what's the last times the last? 9. So this is now what we have to solve. What's x squared plus x squared? 2x squared plus 4x plus 4 equals x squared plus 6x plus 9. What do I have to get it equal to if I have a quadratic that I'm solving? 0. So I'm going to subtract x squared, I'm going to subtract 6x, and I'm going to subtract 9. So 2x squared minus 1x squared is x squared. 4x minus 6x is negative 2x. 4 minus 9 is negative 5 equals 0. What do I check for now to see if this can be what? Factored. Are there numbers that multiply to be 5? What are numbers that multiply to be 5? Will those subtract to be 2? No. So we're going to have to complete the square. To complete the square, I take this over. I've got x squared minus 2x equals 5. We take half of this and square it. What do you get if you take half of that and square it? So if I add 1 here, I add 1 here. So now we're going to have, this is going to factor down into what? X minus 1 squared equals 6. Square root, and so now I'm going to have x minus 1 equals plus or minus radical 6. How do I get x by itself? Add 1. So I'm saying x could be 1 plus or minus radical 6. Guys, 1 minus radical 6 is negative. Can I have a negative length on a side of a triangle? No. So I am not going to use that negative. It's going to turn into a negative value. So that means that this side must be x is 1 plus radical 6. This side has to be 2 more than that. What's 2 more than that going to be? 3 plus radical 6, right. So I have, this is 1 plus radical 6. This is going to be 2 more, so it's 3 plus radical 6. This is going to be 3 more than this, so what's it going to be? 4 plus radical 6. The question asked us to find the perimeter. Did anyone find it on their own? Did you get it, Jackson? Kazuki, did you get it? Very nice. That is correct. Because we have 4 plus 1 is 5 plus 3 is 8. One of these plus another one is 3 radical 6. Okay? Tough problem, but in Algebra 2, that's what we do. We learn something, and then we have to be able to apply it. And we got a lot of stuff going on there. Melanie?
Once you set it up, like with the x squared plus x plus, like the a squared plus b squared plus c squared, could you not just square root the whole thing?
No. And here's why. Let me show you something here. Like, let's take some numbers. Let's say we have 3 squared plus 4 squared equals 5 squared is a true statement, because what's 3 squared? What's this? What's that? Is it true that 9 plus 16 is 25? Good. So what you're saying I could do then is that I could just take the square root of this and the square root of this, and it's going to be true. If I were to do what you were saying, I would get 3 plus 4 equals 5. Is that a true statement? No. So we're not allowed to do that. It would be nice if we could, and the only way we could is if it was like in parentheses as something like x plus 3 squared equals 25. Now we just have one value getting squared, so we could square root it. Okay, that's the difference. And I understand the confusion, because it does seem like it's a similar kind of thing, but it's not exactly the same. All right, any questions? All right. Very good.